Hello Year 12. I'm going to be making some videos and tutorials just to help you out with some of the work that you're going to be doing over the course of however many weeks. We're obviously doing the mechanics course, and I'm going to be going through some of the content and just doing some examples and talking through some of the content to kind of help you out a little bit. So let's get started. Where we got up to at the end of the term is we started to look at Suvat equations. Suvat being 5 quantities that relate things like velocity, displacement, acceleration, and time. And at the very end, we derived 2 formulae that link these things together, which I'm going to do again for you. On the understanding that we are doing this, as it says here, so this is on a specific interval of time, so across a certain amount of time. If you change your velocity, you can calculate things like your acceleration and your displacement from those things. So, based on this picture, this is a velocity time graph. U here is your initial velocity. You accelerate constantly up to a final velocity of v, and I want to know the displacement and the acceleration. So, acceleration, that comes from the gradient. That's the rate of change of our velocity. So, acceleration is, right, I'm going to write it as this. I'm going to say the change in your velocity divided by your change in time. That's the definition of acceleration. So that is, okay, so my final velocity is v, my initial velocity is u, and the time I'm taking in this picture is 0 to t, so t is the amount of change in time. Okay, and that gives us our first Suvat equation, because if you rearrange it, you can show that that means that v on its own, if I solve for v, that's the same as u plus at. And that's your first Suvat equation, okay, and that's solving for acceleration. So working out the gradient does that. If I want to know my displacement, well, that's using calculus. If you integrate underneath the function, integrate under velocity, you get your displacement. So displacement is your area. And because we've got constant acceleration, which is what these 5 equations work for, I've got a trapezium underneath for the area. So if I do the area of a trapezium, I'm going to get half, and then add the parallel sides. That side's u, that side's v. U plus v, I'll try and distinguish them. There we go. Times by the side in between, which is time. So I'm going to write that all at once. So S equals half brackets u plus v multiplied by the time. So these are 2 Suvat equations to start us off. We're going to be using 3 others in the future, but I'm just going to stick to these 2 for now before I prove the rest.